going to continue with our class of hydraulics. And today we are going to refresh some concept about the reversible motors AC and DC. And we are going to identify in the both different type of hydraulic systems, electro-hydraulic systems, electromechanical systems, full mechanical systems, and how to identify each one, and how to convert what will be the process in the future to convert all of them in a central hydraulic system. This is the idea, and this is the class of today. We checked yesterday this picture, guys. You remember the main hydraulic circuit with the reservoir, with the motor and pump. This is the drive unit or head unit. Is composed by the electrical motor. It's composed by the electrical motor, AC or DC, and the pump. The pump suction in the center and discharge on top. No? Yeah. This motor could be DC or AC, depending on the application. And which one is more efficient? Depends. Both of them are highly efficient. Okay, we have the pump and the motor. We have the reservoir. We have the body of valves or servo valve unit or control valve unit. Yeah. And after that, you have the actuator or a motor. Yeah, depending what hydraulic unit you want to move it. And there are different type of actuators. You remember? Single port, single shaft, single port, double shaft, double port, double shaft, telescopic, or single port, single shaft with a spring return, like the twin taps. We are going to check later. Yep, different application depending of where it's located and what is the function. This is the typical hydraulic unit. The majority of those hydraulic units in your boat work with motors, reversible motors, AC and DC. And this is the tricky way to install those hydraulic units, because you need to install the reversible diagram, the reversible equipment to reverse the rotation on the DC or AC motor. I am going to explain right now again, because I explained in the electrical class, the process to reverse DC motors, reversible motors, and AC motors, reversible motor. Remember the three-phase motors? You need only switch one phase, switch the lines of two phases, and immediately the rotation is reversed. Okay, we are going to start with the process to reverse the rotation in DC motors. And we are going to try to connect, to do this diagram. If you have a paper, will be nice. This is the battery. This is a positive bus bar. This is an on-off switch. This is the solenoid control box. The solenoid control box, you remember I explained in the course of advanced electricity, in my marine electricity handbook, in chapter 13, 14, I explained motors, induction motor, reversible motor. This is a solenoid control box, you remember? Where is located this solenoid control box, Captain? On the bow thruster.
Oh, okay.
This is on the bow thruster. It's very common. Look, the power enter here, the big positive enter here, and depending on the position of the signal, send the current for this side or this side, and the motor rotate like this or like this. This is the solenoid control box. Okay, I have the solenoid control box here with the signal, no? Positive, and negative in the middle. All of the solenoid control box, look, 3 positives, big ones, 3 positive, big ones, and the signal, positive, and the negative in the middle connected to the negative bus bar. There are different type of reversible DC motors. This is another reversible DC motor. What is this? Guys, anchor, the windlass.
That's the way to turn it, yeah? Or that's the way.
And this is the motor, positive, and the negative with the body. Okay? Reversible motor. Pay attention to the explanation. Anybody here? We have the solenoid control box. I have the reversible motor. All the reversible motors, they have two positive terminals. Look at this. One positive terminal here, other positive terminal here, and the negative in the middle. In some cases, the negative is in other place of the body. No problem. Positive, positive, and negative. And the solenoid control box, positive, positive, and negative. And the signals. How can I activate those reversible motors in the future? In your boat, for example. The boat thruster with joystick. Joystick. The anchor drum. The up and down button. No? Or with foot pedals on the pulpit, no? Momentary buttons. No? Yeah. Switch. I can activate those three those reversible motor DC with switches. One direction, other direction. Normally, those switches are momentary, not permanent. That's okay?
With the yacht controller.
Oh, exactly. Yeah. That's your decision. That's your decision. Okay, guys. This is the situation. This is the motor, and the motor spin in this direction, or the motor spin in the other direction, in both directions, depending how is coming the signal. Okay, we are going to fit, the number one is to fit the solenoid control box. My friend, if you learn, this is gold in your hands. How many problems, how many situations you will solve in the future with this explanation? Millions. How much money you can make with this explanation, my friends? A lot. All right, I am going to bring power. Where is entering the power in the solenoid control box? In the middle. In the middle. I am going to enter the big current cable with probably you need one fuse over current protector. That's good. And from this one here. Oh, my friend, what is the gauge of that cable? Oh, my friend, depends on the distance. The distance in between the battery and the motor. And you use the tables, the ABYC tables, or the formula in the book. You remember? Circular mills is equal to 10.75 times the length of the distance times 2, because it's positive and negative, times the intensity of this motor, and divided by the voltage drop. How much is the voltage drop normally, guys? 3% in general, or 10% for light. Perfect. Good. Okay. That's the big cable entering in the middle. Okay. Now, in each positive on the side is the output. One big positive is entering here, and other big positive is entering here. Look at this. The positive from the switch selector enter in the middle, and I send one with yellow, with the blue color entering here, and other with yellow color entering in the second one. One with blue entering here, with blue marks entering here, and the other one I am going to put here with green marks entering in the second one. That's clear, guys? And now I need to activate the solenoid control box. Okay, the middle is always is the negative, going into the negative, and the negative here. All the negatives in your boat, are connected together, and they finish in the main negative bus bar in the engine room, and that negative bus bar connected to the bonding or grounding. Thank you. Excuse me. Normally those switches are located where? In the flybridge, in the console. And where are located the batteries for those big motors? Over there, on the bow thruster, on the steam thruster, on the pasarela, yeah? In those, different than the house batteries. For that reason, those switches, they receive power normally from house battery bank or electronics battery bank located in the, where are located the electronic battery bank? In the console, no? Pretty close to the console. The most important is that this negative and this negative be connected together. If not, when I try to send this signal and this signal, if those battery banks are not connected, it's impossible to send the signal. Okay, this is the situation. And now, from this positive, I am going to fit both switches. I have a couple of toggle switches, momentary, on, off, momentaries. And from this one, I go directly to this one. And from the other one, I go directly to this one. And now, if I activate this one, the motor rotates in this direction. If I activate the second one, the motor rotates in the opposite direction. All right, look. All right, I am going to activate the yellow position here. Look, when I turn down this, the red enter here, I go to the yellow, activate the yellow, and the motor is spinning in this direction. Not working, you see? You hear? Click, but no pass. Yeah, you see the current pass through the blue one? Yes. But the relay no pass. The current pass to the yellow one, but the relay is damaged. The solenoid control box is damaged. Okay. This is a great opportunity to demonstrate to the customer that the solenoid control box is damaged. Excuse me. This element is expensive. Is commonly damaged because where is located this element? In the windlass compartment, and a lot of water splashed over there and is corroded. And this is a common situation. That solenoid control box is not working. Okay. How can you fix the situation in the middle of the ocean? With a couple of relays, I am going to replace the solenoid control box for a couple of relays, guys. You remember the relays, the crank relays that we learned in the course of electricity? And other relay here. And after that, big positive, big positive, big positive, big positive. Okay. Once again, the big positives are connected in each side of the relays. Good? Both relays in the middle together and enter. In other words, the current enter in the middle, pam pam, and pass here for this side or the other side. And the signals are coming from this side through this side, from this side through this side, and this one is ground to the negative bus bar, the main negative bus bar. And now I have the situation. It's exactly like this. Look, I am going to activate the blue one. I am going to send the current through the yellow one. For example, in the previous example, the solenoid control box is not working. Okay, let me demonstrate to the customer that if you jump it from the positive into this or from the positive into that one, the solenoid control box is not working. I am going to bring current directly to this point. Oh, nothing. Oh, to this point. Nothing. Let me demonstrate that this is damaged. This is the demonstration. Now, if I bring big current directly here or directly here, the motor spins. This one is connected to the positive of the battery, high amps, and the motor spins. Or here and here, no? Yeah? This is an indication that the motor is good, but the solenoid control box is damaged. If I bring the current here to the signal, nothing. But here, good.